In this video, we're going to talk about polynomials and how to classify and operate with them. But first, a polynomial is an expression with one or more terms. These terms can involve variables or just constant numbers. So when we're first talking about classifying polynomials, we have to look at what's called the degree. And the degree is based on the highest exponent of the expression or the polynomial. If the degree of our polynomial is 1, then we have a linear polynomial. If it is 2, we call it quadratic. 3, we call cubic. 4, we call quartic. And 0, we call constant. Now this 0 degree would look something like this, where the variable that's with my coefficient would have an exponent of 0, which when we simplify, anything to the power of 0 gives us 1, and when we simplify further, we get just the constant coefficient 3, hence why we call it constant. Next, we use the number of terms in the polynomial. If there is one term, it is considered a monomial. If there's 2, it is considered a binomial, and 3 is considered a trinomial. There are other classifications and names for the 4 terms, 5 terms, and so on. However, we're going to stick to these 3 for now, and then anything with more than 3 terms, we will just refer to as a polynomial. So let's look at an example. In this polynomial, 3x cubed plus x minus 2. Notice there are 3 terms making this a trinomial, and the highest exponent is 3, making the degree 3. So we can either label this as a third degree trinomial or a cubic trinomial. Our next example, x squared plus 1. It has 2 terms, making it a binomial with a degree of 2. So we would call it a quadratic binomial. The last example is a little different because it is in factored form. It's not expanded like the previous 2. So when we have factored form of a polynomial, the degree is based on adding the exponents of all the terms we're multiplying. So in parentheses, this x plus 1 is considered a term, and this x minus 1 is considered a term. So the exponent with this first term is 3, and the exponent with this second is 1, which when we add together gives us 4. So the degree of this polynomial is 4, making it a quartic polynomial. Now we can take polynomials and operate with them. So given the function f of x is equal to 4x to the 4th minus x squared, and g of x is equal to 5x squared plus x to the 4th, we can do the basic operations, adding, subtracting, multiplying, and dividing, by combining these. So notice this notation might be a little weird for some of us. F plus g of x is the same as saying the function f of x plus the function g of x, which when I pull from the 2 functions that I'm given, I can literally rewrite them as I did here. I can substitute the equivalent expressions in for f of x and g of x. I write them in parentheses because later on it helps to show this placement. So once we have this written, we can rewrite it without parentheses. Since I'm adding, I'm not having to worry about distributing anything, and so I can rewrite them exactly as they appear. And then I can combine like terms. Now, notice how I wrote the exponents going from the greatest 4 to the least 2. This is called descending order. And we want to make sure that when we're writing our answers for these different polynomial operations, that we are writing them in descending order. Now when I'm subtracting, once again, this is the same as saying f of x minus g of x, which we can substitute the equivalent expressions. However, the difference here is when I rewrite it without my parentheses, I come across this subtraction sign. Well, I have to distribute my subtraction sign to each term, making both terms in the second set of parentheses negative. And now I can combine like terms, and once again rewrite it in descending order. And notice, for adding and subtracting, I have two completely different polynomial expressions. This is very important that you distribute your subtraction sign here. This is where a lot of us will make mistakes. Now when I'm multiplying, it is the same as saying f of x times g of x. Once again, I'm rewriting the equivalent expressions for the functions f and g. Now notice here, I have two sets of parentheses and I'm multiplying. I'm going to FOIL. First, outer, inner, last. And when I do this, 4x to the fourth times 5x squared, I start by multiplying my coefficients, so 4 and 5, when multiplied together, give me 20. And then when I multiply my variables with their current exponents, exponential rules say that I can add my exponents. So 4 and 2 add to give me 6. And I will do this for all the terms using this FOIL. And I can once again combine like terms and write in descending order. Now, the last operation, division, you can write using the division operator, or like what I like to do is write it as a fraction. And when I am substituting the equivalent expressions into this operation, I do it as a fraction. At this point, you can leave it like this, but we can simplify. And when simplifying like this expression, we need to pull out a greatest common factor from the numerator and denominator. So with the numerator, that would be an x squared. And with the denominator, it would also be an x squared, which would allow me to cancel out my x squares and write my simplified expression. At this point, we're going to leave it like this, and in a later unit, we're going to talk about polynomial division.